to get a really creative engineer is a breath of fresh air. It's one of those things where you're after a certain look and a feel, and somehow we have to be able to communicate that to an engineer so that they understand why it's important.
I don't think we put enough value on engineers as designers as we should.
Welcome to Archispeak, a fortnightly podcast about all things architecture. My name is Evan Troxel, and I'm one of your hosts along with Neil Pan and Cormac Phelan. Have you ever wondered what it's like to work in the profession of architecture? Have you ever worked with an architect? Have you ever wanted to be an architect? Maybe you're in school and don't know what you're getting yourself into, or perhaps you know exactly what it's like because you've been working in the profession for a long time, and you know that the more things change, the more they stay the same. Or maybe, just maybe, you're planning on changing the world. Join us as we have a casual conversation about our passion, architecture. It's time for some Archispeak.
Welcome to Season 4, Episode 81 of the Archispeak podcast. I'm Neil Pan.
I'm Evan Troxel.
And I'm Cormac Phelan.
And this episode of Archispeak is sponsored by Arcat. Check out all of the features they offer at arcat.com. We'll talk more about Arcat later in the show. Next up, we have some friends of the show to announce.
That's right. We've got 3 friends of the show this week. We have 1 anonymous donor, and so thank you, anonymous donor. Our second friend of the show is Alex Donkel, and Alex is an AV consultant, and he is all the way over in Hawaii. Very cool to hear from Alex.
Nice.
So thanks, Alex, for becoming a friend of the show. We have another new friend of the show this week, Lauren Schmidt, and Lauren is part of the LandArc BIM website, which is cool. I just say that because you should check it out if you're into Revit and Dynamo and stuff. I spent a little time over at the website there, and Lauren's got a really cool resource. So check it out if you got a chance. Thanks, Lauren, for becoming a friend of the show. If you would like to become a friend of the show and have your name read on the Archispeak podcast, we would really appreciate that. You can head over to archispeakpodcast.com/donate. And any donation over $5 can get your name read on the air. And if you don't want your name read on the air, as we had an anonymous donor this week, that's fine too. We really appreciate anything you can do to help make this show possible.
We'll call the anonymous donor Beetlejuice.
Beetlejuice. Good idea. Insider there. You got to have listened for a long time to know what that means.
What else do we have to announce? Cormac, I think you've been working on something.
Yes. So, we had a pretty good successful run with T-shirts, at the first run and then the recent second run. So we decided to go ahead and launch the Archispeak store. We're starting off a little slow with the standard T-shirt. We do have a couple of new T-shirts that we've added, and we're also going to be adding mugs and things like that as we evolve. We're also working on some new designs that aren't quite ready for press yet, but I think everybody's going to love them. They're going to be right up our alley, and we'll make further announcements later, later as they become available. But
the important thing is that now you are committed, Cormac.
Now I'm committed. Yes,
it's going to be awesome.
Yes, they are coming from the mind and hand of Cormac.
Nice.
Although Evan's responsible for these great T-shirts that we have now, and
those are old.
We got a new T-shirt coming.
That's right.
From Evan, and we'll just start adding stuff to the store as it becomes available. And I think when we launch those particular sketches and stuff, I think we're going to do it as a group so that there's more than just one.
Cool.
To get offered.
Nice.
And you can find it at archispeakpodcast.com/store.
All right, so we wanted to talk about a couple things this week. That there's one of these is right out of some furious text messaging that Cormac has sent over. And that, to me, really is about the value of a good engineer. And the reason I say that is because we work with so many bad ones. At least I have. I won't talk about that for everybody. But seriously, it's amazing the difference that a good consultant can make on a project, right?
And it comes from so what you're referring to is that I've been working with a couple of engineers recently that it's almost like pulling teeth to get them to either agree or be adventurous on a design. And when you keep giving them some parameters, like let's make it light, let's do this, let's do that, and you keep coming back with these big bulky details that look like you're designing some traffic engineer's version of a bridge or something like that, and you're something that you're tacking onto a building, and you're just like, oh, this is huge and bulky. There's got to be a better solution. And you're always kind of pushing them. And I understand that it's a whole collaborative thing, but
there's not always time to be collaborative or the means to do that.
And a lot of times, you're looking for them to provide design input through their engineering. And I think that's a huge thing, because there's basically the designer type engineer, and then there's just and I don't want to trivialize it and just say engineer, but that's essentially what they are. It's just they will give you just what you're asking for and won't be adventurous in trying to come up with something creative. I mean,
creative is the word.
Let's take, for instance, a structural engineer. And you say, hey, we've got all this architecturally exposed structural steel, but we want to get really adventurous with this. We want a great detail that for the connections and how the termination plates come into the ground, or this, that, or the other. And you think that this is a time that they want to shine and they want to like really do something amazing, and then they come back with just kind of like your standard off the shelf stuff, or it's big and boxy and bulky and stuff, and you're just trying to really push them into doing something more. And, sometimes it's hard. Sometimes it's easy. I mean, sometimes you get, really good engineers that can really kind of push the design and help steer the design. I'm, working with people right now that, are really kind of contributing to the design and working through some really cool things. And really, to be quite honest with you, they're things that I've never done in my career that I'm like, oh, wow, this might actually be one of the best things that I've ever done or have ever been involved with.
Yeah, I've got some similar experiences too. And I also think that we should say that there are the same people working in our architectural offices like that we're describing here, right? There's people who are going to do things creatively, and then there's other people who are going to either give you exactly what you want or maybe even dumb it down further.
Exactly.
And I say that because like not all of our ideas are super creative, and not everything has to be. But there are opportunities for creativity in things like you're talking about, and it's amazing the different output you'll get depending on the person that you ask.
Right. Because you're going to have a kit of parts. I mean, everybody knows that a bolt is a bolt. I'm going to kind of stick on the subject line of structural engineer, because I've had a good, like I said, good and bad experiences with structural engineers where it's like, okay, here's a truss design, or here's a truss profile that we would like to have in this particular building. It kind of incorporates. I'm thinking about a project that I had probably about, I would say 10 years ago or so, that this truss kind of incorporated different pop-ups that created clear story condition. And they're looking at it and they're like, oh, we can't do this because it creates a moment here and it creates a moment here. And ultimately, at the end of the day, it wasn't that they couldn't do it. It's that they just either didn't feel challenged, or they felt like, I don't know what it was. But at the end of the day, they did it. And it was just a real simple shed truss with a small portion that was a flat roof to create the clear story condition. It was kind of like a little sawtooth. And it was a real simple, honestly, it was a real simple, no nonsense truss. And it was like pulling teeth. And it would have honestly really changed the dynamic of the design if we had to dumb it down to something simple. And even though I thought it was something simple, it was really hard for them to have the vision to see it. Whereas, like I said, kind of currently, we're working on something that is some interesting structural gymnastics, because it's adding structure to an existing building in a way that we're essentially cantilevering a structural framing system to carry some vertical fins, some terracotta vertical fins, and it's actually going to be pretty cool. But the detailing and stuff is something that is still taking the kit apart. It's still taking the plate connections and the bolted connections and diagonal tie rods and all of this stuff. It's simple things that are in a kit of parts and just assembling them in a different manner. And some people feel really uncomfortable getting out of that comfort zone.
Yeah,
and some
totally.
people feel very comfortable. Or even maybe they didn't first think about it, but that's the value of the collaboration between a structural engineer and an architect, is being able to talk things through, where first you may start off with, like, say, in this particular case, we kind of started off with like a square tubes, and they looked really bulky in profile. And then as we kind of like worked through it, it basically turned into just these pipe columns and things like that really kind of made it look a lot more delicate.
Yeah, and
so
you've got some knife plates. You've got these nice little rod connections, and it has a level of elegance to it, and you can tell by looking at the drawing that that's what you're after. And I could only imagine if you bulked all that stuff up with square tubing, where even just by changing it to a round tube, just the way that you perceive it and the way the light hits it, it appears thinner, and that's what you guys are after.
Yes.
Right?
Yes.
And so for an engineer to think outside the box, or to go for a detail, I mean, this is not a new detail, right? Let's be honest.
No.
But it's one of those things where you're after a certain look and a feel, and somehow we have to be able to communicate that to an engineer so that they understand why it's important. Otherwise, they kind of do just take the easiest road to get there.
Good luck with that.
Yeah. Well, I joke with them. I'm like, it would be the easiest thing, is if we can master levitation, because, we're trying to take these really heavy material and basically have them float in front of a glass,
right?
A glass curtain wall. And when you look at it, you're like, oh, this is, the complexity of this simple design or this simple move. The things that you want to make look simple are typically a lot of times the most complicated.
Oh yeah, this is also something that's not new, but if you look at Mises Buildings or Craig Elwood or any minimalist modernist, it's like that is the hard stuff.
Oh yeah. I mean, to make glass float, or to make a large planar cantilever of a roof or something like that, as simple as the forms are, as simple as the moves are, it's the most complicated thing to make something look like it's floating.
Skyhooks.
Exactly. Because a lot of times we just hide things behind, I'm going to put a bulkhead here and I'm going to hide all the structure behind that, or here's a soffit that's carrying and like hiding stuff. But, when you want it to kind of like float, it's an interesting challenge. And, the thing about it is that, I don't think we put enough value on engineers as designers as we should. But if you treat them as part of the design team, and I'm using design in air quotes here, that they are a designer as well as the architect, you're going to get a better resolution in your designs. If you're just treating them as, okay, here's my design, make it work. Mm-hmm. They don't have to get creative because you're not asking them to. They're not going to get creative because you're not treating them as, an equal in, this whole thing.
I wanted to ask you, how do you work with your engineers typically? Are you able to treat them as part of the design team, or I mean, how does that work when it comes to the larger, school type projects that you work on?
Well, it's hit or miss in, a lot of times, especially in Evan, I know you know this, when you're doing like public work stuff that's cheaper, well, not cheaper, it's your budget is really low or your budget is really tight, and that you're holding to a very tight per square footage cost. I think that, to me, is where you really get to be creative with the structure, because you really are going to have a more dumbed down structure. But how do you get creative with that dumbed down structure? And how I usually work is, and a lot of times architects, and I've worked at firms before where, architects won't bring in a structural engineer till after SDs. So it's just like, okay, well, we've worked out what we wanted to do. Now you just got to kind of make it work. To me, that's being kind of, I don't know, almost disingenuous to the process, where here's somebody that you're going to be relying on to make your vision work. Why not talk to them a little bit early about, hey, I'm thinking about doing a stair with just a single center stringer, and the stairs are floating. They're just these floating planks that teeter at a center point. Well, that's pretty complicated stuff. Let's get them in early. Let's talk about it. Let's make sure that we can actually do this and make it work and, meet all of the code requirements as well as being something very decorative. And I think, getting people early on in the process, especially like in, say, renovation work, where I've been doing a lot of, renovation work over the course of the decade or so, where, you've got a complicated program that you're trying to push into a pre-existing box. And 9 times out of 10, that pre-existing box did not have air conditioning, didn't have fire protection, didn't have all of these things. And now you're supposed to make it work and also be a nice design and a nice, comfortable building, and something that is encouraging of, like, say, educational programs. And so that's when you really get them in early to be a part of the overall conversation. We had this one project where I had from finished floor to top of structure was 11'6". You guys do the math. That's not a lot of space to jam in all of the services that you need to jam in and still have a ceiling higher than 8 feet.
Yeah.
Now, so, getting in early and talking to them about it and trying to figure out a solution that, could have a good design as well as good systems kind of coordination. And it's an interesting challenge. Yeah. And it's a fun challenge to me. It's both frustrating and encouraging when you're depending on the type of engineer. If you're working with an engineer that's just kind of unwilling to think outside of the box, your projects will suck.
Especially in the public work that we do, where everything is beefier because it has to be.
Right.
It's even harder, I think, to work with an engineer who is used to working with those agencies, and they kind of have a feeling that we're not going to be able to do that because they'll never approve it. And so the compromises happen very early in the project, right? Before anybody's had the chance to actually say that's not going to work. And I get it. You don't want to have to go back and redo something that late in the project. But at the same time, the longer we do these types of projects, the more neutered we get with ideas, because there's been so many things that have been denied because they just won't allow it. And these are things that I'm talking about are way more restrictive than the typical code, especially in the public sector.
Yeah. And actually, you bring up a good point, because a lot of times the reason why we wait to bring an engineering in is because we don't want the engineer to... So we go through thousands of iterations of a design, and, there's stacks upon stacks of trace paper that we've, burned through. And a lot of times the fee is built so that the engineer themselves, they don't usually have, a fee built in for you to be able to have them work on thousands of different iterations.
Yeah. Right.
They're looking at that. Okay, you tell me what you're trying to build.
I only want to do it once. And they won't even start until you're done with DD, right? Because they know how many times you're going to change it.
Yeah. And even though your submissions are supposed to have, basic, like maybe a single line MEP drawing, or, outlet layouts and things like that, or, a structural diagram, they're like, well, we don't want to start until your DD is approved, so that, we're only coming and doing it one time. So I think there's, we're kind of handicapping ourselves in the way that the fees are based, where what we're doing is limiting their ability to kind of get in, roll their sleeves up, and be as creative as we are during the whole design process. I mean, okay, well, we've got all of this ductwork that we're supposed to get into a clear space of, say 3 feet, and it's got everything else in there. And so what do we need to do with it? How can we be creative so we can, make everything else kind of feel open and kind of inviting, or whatever.
Yeah. We
need to kind of reconnect with putting a value on a design engineer.
Yeah, I've had a couple of experiences, one recently and one a couple of projects ago, where I've had that great experience. And it really totally depends on the person, not necessarily the firm. I think some firms are going to be better known than others. I mean, obviously, if you're going to like a facade consultant like Thornton Tomasetti or you're doing Bureau Happold, you're going to get something where they're thinking outside the box. That's why they're hired, because that exact reason. But the typical engineers that we work with, the smaller shops that are doing the type of work that we're doing, and they're turning it around in record time, and they've got tons of projects going on, and you can tell it's kind of like the environment we work in now. To get a really creative engineer is a breath of fresh air, especially structurally. I think, if we continue on with that kind of specificity of the type of person we're talking about. Recently on a project, I had designed this main stair in a lobby, and I had it coming down and hitting the ground at the midpoint landing, and he's like, we could float that. And just those words right there.
You're just like,
it's like, oh, really? Because I'm coming from a different point of view where I'm thinking we'll never be able to float that.
Yeah.
And when he says we can float that, I latched onto that. I said, okay, how are we going to do that? Because this is the one point in the building where it actually deserves for that to happen. And so, again, if the engineer understands the whole building and they understand where it's important to spend a little bit more money on a solution like that, is super cool to work with. Another guy that I worked with on a high school, it was all CMU. This entire $120 million high school is CMU because of durability and maintenance and all these things, right? Really driven by the maintenance person. I wanted to do this cantilevered trellis off of one of the walls, and he's like, we're going to have to put columns out here. And I said, well, what if we punch holes in the CMU and we backspan the steel back into the roof diaphragm? He's like, I like that idea. And as soon as he said that, and he's like, I really like working with you because you're making me think. That's exactly what he said, right? You're making me come back. And I loved working with him because he was willing to explore. And to me, that's the value of a good engineer, when you can develop that kind of a relationship or that kind of a dialogue to where you guys are bouncing off each other. And you know that this is going to be a good marriage because the architecture and the structure rely on each other so heavily to do some of the things that we want to do. And it goes for any consultant, really. But in this particular case, it was really cool. And then like a couple weeks later, he was taken off the project because he was spending too much time on it. Oh, talk about like taking the wind out of the sails, right? It's like, okay, now we will put the columns back in because that's the fastest, cheapest thing to do right now. And that kind of stuff really sucks. And so we've got consultants where they are ultra conservative and the steel is twice as big as it needs to be. And there are columns where you absolutely do not want columns. And it's like, no, really, can't we just thicken the steel on this beam and make it span further? Well, yeah, we could do that. But so then why do I even have to ask? And I think that's one of the comments that you had made over the text was like, why didn't you just do what I asked you to do? Because now you're saying you could do it. But before, when I showed it to you, you did something different.
Yeah. You give them your overall design concept, and they see what you're trying to do, and you say, okay, here are a kind of like some buzzwords that I want you to keep in the back of your mind of what we're trying to achieve with the design. And then they kind of come back and they're like, well, here you go. And you're looking at it like, man, this is like bigger, and it's almost the opposite of kind of the design concept.
This is exactly the wrong thing.
Yeah. And then you sit there and you talk to them about it and you work through it and you maybe sketch and design back and forth and then you send it to them and they're, oh, well, yeah, we can do that.
Yeah. Oh, shaking my head, right?
Yeah, exactly.
Well, you guys missed it. You left before Junya Ishigami spoke at the MDC last year. And he, if you look him up, I guess we could put a link in the show notes to his projects. They are like, I don't even know the right word. I guess slender is a good word to use. And you again, I just feel like, oh my God, like I'm working in the worst field possible, which is public work in California, right? With our issues that we have out here laterally, to look at his images, because I look at his and I'm just like, how do you do that? Right? They are like thin as air. I don't even know of another way to explain it, but you've got to look at his projects to understand what I'm saying, because the columns are, like the building is made out of columns that are actually just 1/2-inch steel plate. That's all they are. So that you look at them and you barely even see them.
Wow.
or he holds the roof up with glass. I mean, it's the kind of thing that every design architect wishes they could do. He actually does them. He figures out ways to do them. And the only way that he can actually do this is by working with an engineer who gets what he's going for.
Well, but so here's actually another thing, and I think that we're kind of putting a lot of the onus on the structural engineer, on expecting them to basically think what we're thinking.
Yeah,
and I think some of what we need to do is understand what they do. So the value of learning in all of these structures classes that we take in architecture school, the value of those classes is that we'll be able to have the dialogue with the structural engineer about what we're trying to do with steel and understanding the properties of a tube steel versus a pipe column versus a wide flange and all these other different things.
Why would you use one instead of another in this? Because of rotational torsion and all these really interesting stuff. If we would just get into it, I agree with you.
If they say, well, we need this column in here because we need the lateral bracing, you should understand what lateral bracing means, or the shear columns, or whatever. You need to understand some of these things so that you're not dependent on them designing your building. Yeah. You're working as a collaborative team designing the building.
Yeah, it's interesting because once you understand the concepts of what they're doing, so for instance, I'm working on this science building similar to, I guess, what you're doing, Cormac, and it has to be a really stiff building because of vibration requirements.
Yeah.
And we've got like 21 braces in this 3-story building. And I don't mean like those are spread out over floors. I mean, that is on every single floor because they go from ground to rooftop. And that is a lot of diagonal bracing in the building. Mm-hmm. And it's what's kind of cool is we're using EBFs, eccentric brace frames. And for the most part, they're A's in the shape. But every once in a while, we switch it to a V, and that's because of door locations where we're actually having to pass through the brace to create an opening. And It was kind of cool how we got there because we'll have 3-story brace frame. You can imagine, you've got this big rectangle, and it's divided into thirds, right? So you've got 3 different openings, and in each one, you either have to have a V or an A. And originally, they were all A's. But in one location, we said, we've got to have the door right here, which goes right through one of their V's or A's, and say, hey, what if we flip it right there? Yeah, totally. You can do that. You can totally flip it right there. So we've got this kind of mixed bag in certain locations where it might be A's on 2 floors and then a V on the top floor. And it's cool just to, I wouldn't have known that unless I worked on this project, that's even something that we can do. And so now, from now on, I get to say, okay, well, let's flip this one and just make the process go a whole lot easier.
Or what you're now learning is, okay, so I'm going to have diagonal bracing within this building because, I'm trying to keep an open appearance, and so I'm not having any, kind of like shear walls or anything in this thing. So I know that we're going to have like end bay bracings or whatever. So now you're learning, it's like, okay, so how can I design that in at the next project?
Yes, exactly.
So that I can actually celebrate this design. And then if you're starting to talk to your engineer about, okay, so we're going to express your structure. Then they start to think, okay, so now it's going to be out in the open and it's going to be visible. Do I want to do this this bracing with this big clunky wide flange with a couple of angles, or do I want to do it with tube steel or whatever that kind of make it really light and thin but still achieve the the criteria that I need to.
It really is on us to listen to them too. So yes. They're listening to us in that, and then they're gonna throw back ideas, and it's really important to listen to exactly what they're saying and why they're saying it. Well, I want to use tube steel here because, or they'll just say I want to use tube steel here, and you have to ask why, so that you can learn from it.
What was great is so the engineer that I'm working with right now, he's got this, he's got a more of a pragmatic kind of approach for certain connections and stuff. And they make perfect sense. And I think he and I talked through wanting to do certain kind of, architectural enclosures to, where we're penetrating the steel through the curtain wall system. Well, once you do that, you've got to figure out a way to close that hole. And so, we talked about, different ways of doing that to kind of make the structure either square or something that I can kind of close around it and make a nice, good seal. But then, we started talking about plate connections and like, oh, well, what if I run the blade between two mullions and things like that? And, so it's just this kind of like dialogue of what is the easiest way to create this end appearance, and how do I work backwards to a structure to get it that way? And can't stress enough the value of being able to have each other kind of speak each other's language.
Yeah, I think it's also important for your firm to kind of identify, or you as a practitioner to identify who those people are so that you make sure you work with them again and give them the business. And then also with the ones that you don't like working with, there's got to be some way to say, here's why I don't like working with you guys, because you're way too conservative. And we've done that before on projects. Sorry, we don't like to work with you guys because, or this particular engineer on your team, because we don't get what we want out of it. It is up to us to say that, and to maybe have some kind of a vetting process where we can, to other teams, recommend certain engineers or consultants based on performance on past projects and different experiences that we've had. It makes sense to me, right, to know in my firm that, okay, I really want to work with this engineer on the next project, so hopefully they're the ones we pick, versus I definitely don't want to work with that engineer because it's just a headache the whole time.
Right.
That would be a good thing for firms to have, is that type of a resource, I think.
Yeah. I mean, we get pre-qualified by clients all the time. We should pre-qualify our design team. Yeah. If they would only do that to the contractors.
All right, let's talk about ARCAT.
All right, so our sponsor, ARCAT, for this episode. What's the one thing we all do in our practice? Search the internet for content, right?
That's right.
Well, we want to let you know about arcat.com. ARCAT is an online resource devoted to bringing content to the building professional. They have huge libraries that you can access, and they don't hit you up for subscriptions. There are no fees, and they won't make you register to download the content. We've all been there. You finally find the right file, and you get blocked with a registration pop-up, and you think,
oh, yeah,
thanks for wasting my time. I'll find it somewhere else. ARCAT's BIM library is really second to none and available in just about any format you need. In fact, their entire BIM library is formatted for the last 5 versions of Revit. Their CAD detail library has thousands of CAD details, and if you ever need specs, the ARCAT library is the most consistent library you will find. Every single spec is written in the CSI 3-part format. There's so much more on their site, including catalogs, videos, and Spec Wizard. Go to arcat.com or download their app and check it all out. It's a great free resource that you don't have to register to use. Visit them at arcat.com. That's ARCAT.com. And thanks to ARCAT for sponsoring this episode of Archispeak.
We've been rushing for pulling together a GMP set, and we've been needing to pull in a lot of content for these bidders to understand kind of the design content, because it's pretty early in the CD phase for them to be doing this, but because of scheduling and everything else, we have to. And I swear I basically left the tab open for ARCAT and just kept jumping back and forth between it. So there isn't one specific one. It was wholesale project. Every bit of I was pulling stuff out of ARCAT to pull this set together to get as much information, spec-wise, detail-wise, everything. So they saved me again.
Nice. Well, Neil, I would be interested to hear how, in the residential side of things, your dealings with consultants.
Yeah, it's very similar to your experiences. I think getting the engineers involved early always helps. Although I found with residential, and most of what I do is not high-end custom residential. It's more lower end and more simple things. In addition to my previous work doing more production housing, the engineers really kind of come in late in the game. As you were mentioning, Cormac, that's part of the problem. They come in so late that you're trying to fix problems that were created during the design process, where you could have avoided them if you'd gotten everyone involved a little bit earlier. Yeah, I've always been a huge advocate for that. So but it's always a challenge, and definitely different engineers give you different levels of service, just like architects, right? Yeah. So, I've had plenty of experiences where it's almost where you kind of get what you pay for. The cheaper the engineer, the less they do, right?
The more you have to do for them.
You have to spend fixing their stuff.
Totally. Goes right back to my gripe earlier about not wanting to work with certain engineers. And that's the reason right there. It's because I'm laying out their ductwork. Okay, you guys can't figure it out. I guess I'm going to have to figure it out for you. And they're like, thanks. Right?
Or it's just like they're going to just throw it out there. And it's just like, okay, well, here's your corridor. I'm going to run, this bit of duct, down this corridor. I'm like, yeah, but we've got this and this and this and this and this. You need to be a little bit more creative so we can have room for everything else. We're limited in our space. And so you got to basically kind of either push them to do it or find that one creative engineer. And it's not one. I mean, there's tons of good engineers out there that are really creative and want to do something because to be quite honest with you, 9 times out of 10, every engineer that you work with, they're like, well, you're just going to cover it up with the finishes, so you're never going to see our stuff. Well, like in the case of this particular chemistry
but that's an art.
I'm doing, in this chemistry building, they don't want ceilings, so you're going to see everything. So how do you get creative on the routing and the layout? And this is a time for you to design. We're going to see your stuff. So let's lay out the artery system the way you would love to see it kind of showcased. And, when you put that on the table for them, they're like, oh, this is going to be great. And you get their energy level up and they want to do something that's really creative and really kind of outside of the box. Because now they've got an incentive to do something cool. Well, even when you are covering it up, a lot of times you still want them to be creative because you've got other things that are going on, underneath the skin of it all that you really need them to kind of be creative to work around all that stuff.
I think one of the things architects oftentimes forget about is when they're setting up their budgets and their, what's a project going to cost us and figuring out that we spend a lot of time trying to understand how long it's going to take us to do our portion of the job.
Oh, yeah.
And what I think sometimes gets forgotten, and something that shouldn't be forgotten, is coordination time. Because as I found, even with the smaller, simpler projects that I've done over the last few years, just even something as an addition, when you've got new foundation area and you have to connect these foundations. I mean, not necessarily connect, but you have a crawl space, and that crawl space has to connect to the new crawl space. You can't just wall it off unless there's a second access right from the floor. And so a recent project that I had, the engineer completely ignored that, and so I had to spend time reviewing his drawings, which you have to do some amount of as well.
That's
but
your job.
I'm not checking his calcs.
But you are responsible for your consultant's works.
What's that?
You are responsible for your consultant's work.
Well, that's true. And so I'm looking at it and I'm like, dude, you didn't even put in the accesses here that we need to, go from one space to another. Oh, yeah, I got to do that. Or just completely forgetting things or doing things completely different from the design. That's the one that really gets me. It was like, didn't you look at the way I laid this out? Because your engineering doesn't match my architecture.
Communication.
Well, yeah, it's that. But I find that it oftentimes comes down to the quality of the engineer or the time they want to spend or the fee that they're charging.
Yeah.
And all of that kind of goes together.
It all plays together.
Other engineers where I get a phone call. Hey, Neil, this isn't quite working out, or I'm having this issue. And I'm thinking, mostly on the structural side, but I've had the similar experiences with, HVAC consultants as well, even on my own house, where I laid out, or I didn't lay out, but I had, I could recognize just from my own experience how I was going to need to get ducting down to the first floor. And so I had boxed out areas for them to run their ducts, and then I get the layout back from the HVAC contract or consultant, and they had run things in all kinds of weird places and said, "Oh, we need a chase over here, we need a chase over here." I was like, "What the hell are you doing?"
So
I've
Neil,
already
you got this
done
covered
it for you.
They're like, Neil, so you got this covered by this this new soffit, and you're like, there's not supposed to be a soffit there.
Yeah.
Oh,
well,
but yeah, but
How do you feel about exposed ductwork?
I mean, that's literally exactly what happened. You know, or the worst case. The worst case is a number of years ago on a project. This was more of a very tight, not quite multifamily, but single family, but attached. It's multifamily sort of project. But anyway, long story short, none of the coordination was done during the process. And so at the time I was working for a developer, and we bought the project off of another developer, and we kind of came in midstream of construction. And so we were walking around and realizing that there was no coordination done on these 3-story buildings on how to do the HVAC. So we're literally standing in the model or in framed buildings going, how are we going to get this duct over to here and to this room and up over here? I mean, that's just ludicrous.
Well, this is the value of BIM, right? This is where we are solving these problems.
I don't know how much BIM layout would be doing on these residential type projects.
Well, I think that they would work for any size project, and I mean, you guys can see the. I posted an image to Twitter this week of a project I'm working on, and you can see. I guess I could put one in the show notes of just the systems, because it is ridiculous what is packed into this building. And Cormac, you know how heavy the infrastructure is in these science buildings. And this is my first science building, but I'll tell you what, everything that I've learned in this science building is going to apply to every single project I do from now on. Right. Because we set it up from the beginning. We've got 16 feet floor to floor. We've got this thick of a slab. We've got this much margin for structure. We've got the next layer down is HVAC. The next layer down is sprinkler pipes. The next layer down is this and that. We've got data packed in there. We've got hot and chilled water. We've got all these different things. We basically created like the stratification that runs down the hallways, and we know that it's going to fit within this certain width, which, by the way, it doesn't really. It would be better to be wider. But we look at all these things, and we're making decisions early on. Okay, our floor-to-floor needs to be this because we need to stay under this height limitation for the building type. Or we need to save money, right? The bigger the floor-to-floor, the more it costs. Structurally, the building weighs more. There's all kinds of problems with that. We got more drift. But just setting up kind of these ground rules for zones, I'm going to use that everywhere now. And when I go back to those other consultants I'm talking about, where it's like, no, really, I wanted the duct in the ceiling. I didn't want to see it. I didn't want it halfway through the ceiling. You know, it's like you shouldn't even have to say these things. But really, that to me is the value of BIM, is like we can actually go through and coordinate all this, where it used to be kind of halfway done by us, halfway done by contractors. Right now, it's like we're really trying to solve these problems before it ever gets built. And so I feel like that really is a reason why it's great to use BIM.
Yeah, I'll tell you another reason why it's great to use BIM. So in this particular building, because it's a renovation building, we have the floor-to-floor height is 11.7. Well, you know, if you think about it, standard construction, that's not too bad. I mean, it could be a little bit better, but it's not too bad. Well, in this particular case, it's got a waffle slab, and it's got perimeter beams, and all of these different things that are the perimeter beams are 36 inches deep, concrete beams that, you know, we're trying to get ductwork to pass under. Well, you know, you start doing the math on how low these things become. You're just like, ugh. So then you start to become, you know, you really start to look at how creative you can be with this existing waffle slab and the depth of this slab and everything else. And BIM in this particular case has been an absolute lifesaver, because there's certain criteria that, you know, all of the lab equipment needs. I mean, you know, here are instrument sensitive labs that have certain height requirements for their, you know, fume hoods or their glove boxes and all these other different things that go into this particular building. And, you know, then just the criteria of what clearance they need for, like, say, a laser lab. Yeah. And you lay that into what you would normally lay into a building, and it's amazing how quickly all of that space gets just snapped up and completely used. And you're like, okay, so now, you know, if you look at it and you're just kind of laying it in normally, we'd have to, you know, like all of our duct would be at, like, you know, 6 foot. So it's like, okay, now how do you get creative? And that's when like the creativity of the engineer, both the structural engineer and the mechanical engineer working with the architect to be able to pull what would normally be just 6 foot clear to now at least give them 8 foot clear so that the lab can actually function as a lab.
Yeah. Exactly.
And so that's where the creativity really comes into play. And BIM, I swear BIM has been a savior after savior because we're like overlaying things. And if I can, before the show goes live, I'll try to find a section cut through the building that we did, showing all of the different utilities jam-packed in there. And it's amazing to see, the lab equipment, modeled in there, all of the structural systems, modeled in there, including the existing and all of the arterial work of the MEP. That's
cool. It's cool stuff. I mean, it's really cool to see that and to think like, man, we've done this in how short of a period of time?
Exactly.
It's crazy. Exactly. All right. Well, that seems like a good place to stop.
I'd like to remind everyone to visit the website at archispeakpodcast.com for links to our catalog of episodes. You can also sign up for our newsletter that includes links to everything we mention in each episode. Between episodes, join the conversation by leaving comments at archispeakpodcast.com and on our Facebook page, or even talk to us through Twitter. Links can be found for all of these by visiting the site at archispeakpodcast.com. Thanks for listening, everyone.
Bye.
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 You have to walk it, you can start now, or you can hang your head in despair. It's the only road to take you there. They may tell you that you'll never recover, baby. I bet one thing or another about you. It's the only road to get you there. And if they don't know how to treat a lady, maybe you can teach them how to act. They could use a little bit of discipline and a hand on the backside, baby. Let's pretend we're doing the right thing. And while we're at it, have the opposite day. Some like to hug, some leave a bruise, some need to go. I'm ready for you. Hey, put your skates on. On once again. Hey, hey, on. I think you like it. Escape song. Great song, the real world. It manufactures glory for the feeling distractions. Photos and truth like a tractor. A cracked actor, a mother of pearl. And if they don't know how to hold a woman, maybe you can put them back in their place. They could use a little bit of discipline and a hand across their face.